Section 2 in Chapter 9 we split into a couple days, and we're going to be doing some identifying with quadratic functions. So we want to be able to find the zeros of the quadratic function from its graph, and we also want to be able to find the axis of symmetry and the vertex of the parabola. So the first is a vocab term, and it's the zero of a function. The zero of a function is an x value that makes the function, or y, equal to 0. It's the exact same thing as the x-intercept of the function, and a quadratic function may have 1, 2, or no zeros. So it's the x value that makes the function equal to 0. Please make sure you write this definition down. So if we look at the graph of the quadratic function, we want to be able to find the zeros of the function from the graph, and then we also want to check our answer. So we're told the function is y equals x squared plus 8x plus 16, and it is graphed here for us. So when you're looking at the graph, you're basically looking for where does the graph cross the x-axis. And those are going to be your zeros. So here we see it doesn't actually cross the x-axis, but it touches the x-axis at -4. So one of our zeros is x equals -4. Now remember from the previous slide, the definition, it says that our parabola may have 1, 2, or no zeros. And then the question is, does this graph cross the x-axis anywhere else? And it does not. So we just have 1 0 here. It also says to check your answer. Remember, when we check our answer, we're going to plug that x value in, and we're going to verify that we get 0 for y. So when I plug in a -4, squaring -4 plus 8 times -4 plus 16. So that gives me 16 minus 32 plus 16. Well, 16 minus 32 is -16 plus 16. So we do get that y equals 0. We've checked our answer. We've verified that the 0 from the graph does in fact make the function equal to 0. Let's look at another example. Here we have the function y equals x squared minus 2x minus 3. And again, it has been graphed. So we're looking for where does the graph cross the x-axis. And you can see it crosses here in 2 places. So we're going to have 2 zeros of the function. One is at -1, and the other one is at +3. So we have x equals -1 and x equals 3. And we want to again check our answer, so we're going to plug the -1 in first. That's -1 squared minus 2 times -1 minus 3. Just watch your signs here. That's 1 plus 2 minus 3. 1 plus 2 is 3. 3 minus 3 is 0. So the first 0 of -1 is correct. Let's check the next one. We get y equals 3 squared minus 2 times 3 minus 3. So that's 9 minus 6 minus 3. 9 minus 6 is 3. 3 minus 3 is 0. So this one also checks out. Remember again, the zeros of the function are basically the x-intercepts. Where does that graph cross the x-axis? Again, it's the value or values that make the function up here equal to 0. Now we have y equals -4x squared minus 2. So you can see the parabola here has been graphed. It's a downward opening parabola. Remember that the a is negative, so that's how we can tell it should be downward opening. And this graph actually does not cross the x-axis. You can see it starts below the x-axis and then it continues downward. So it's never going to cross the x-axis. So here we have no zeros. And there's nothing to check. So we've talked about the zeros of a function. Now let's talk about the axis of symmetry. The axis of symmetry is a vertical line that divides a parabola into two symmetrical halves. It always passes through the vertex and is the x-coordinate of the vertex. And we write it as an equation of a line, x equals some number. Remember that all x equals equations of lines are vertical lines. And I put in this definition that it's imaginary because it's actually not part of the graph. When we draw in the axis of symmetry, we draw it in as a dotted line because, again, it's not part of the parabola or part of the actual graph. So let's find the axis of symmetry. When you have the graph, it's pretty easy to do. You're looking for the vertex, and then you're going to draw yourself a vertical line through the vertex. This is your axis of symmetry. Notice it splits this parabola into two symmetrical halves. You could fold this graph paper right on that axis of symmetry line, and the two halves of the parabola would match up. But we need to actually state what the axis of symmetry is. Remember, it's a line, and I'll abbreviate axis of symmetry AOS, and it's an x equals line. And from the definition, it says that it's the x-coordinate of the vertex, or we can just look at where does it cross the x-axis. So we can see here it's crossing at -1. So the axis of symmetry is x equals -1. It must be written as an equation. Okay? If you just write -1, you're going to not get credit. And again, if we wanted to look at what the vertex was and label the vertex is -1, 0. So you can see that this, the x-coordinate of the vertex, is also the axis of symmetry. Okay, let's try another one. Here we need to find the axis of symmetry of this parabola. So you can see the vertex here. It's not actually labeled or marked, but our axis of symmetry would be a line that extends through the vertex. Now here it may look like it's falling right in the middle of two x values, but since we aren't 100% sure that that's what happens, we can actually use the zeros to help us find the axis of symmetry if the vertex isn't falling right on an exact whole number. So this time, instead of just being able to say x equals some number, because we're not exactly sure where that crosses, we're going to use the two zeros. So first we have to figure out what the zeros are. The 0 here is 1, and the 0 here is 4. Remember that that axis of symmetry divides the parabola basically in half. It splits it into two symmetrical halves. So if we figure out the distance between these 2 points and then divide it by 2, we'll be right in the middle. You're basically finding the midpoint, or you're even, you could think of it as finding the average. So we're going to take the two zeros and add them up. Then we're going to divide by 2. So we get 5/2, or you can say 2.5, or you can say 2.5. All three answers would be acceptable, but remember the axis of symmetry is written as an equation, x equals. And I'm going to leave mine as the improper fraction, 5/2. So if you aren't able to tell from the vertex where that axis of symmetry crosses the x-axis, you need to take the average of the two zeros. Here's another one if you want to pause the video here and try this one on your own. If I draw in the axis of symmetry, it's going through the vertex, and it's crossing at -3. So we have x equals -3. Remember, it's also the x-coordinate of the vertex. If I were to name the vertex of this parabola, it's -3, 0. So there it is, the axis of symmetry. Okay, now if you don't have the graph, there's actually a formula to help you find the axis of symmetry. And for a quadratic function that's y equals ax squared plus bx plus c the axis of symmetry is the vertical line x equals negative b over 2a. Remember where a and b come from. A is the number in front of the x squared, b is the number in front of the x. So when you're just given the function, we'll do some examples. The axis of symmetry is found with the formula negative b over 2a. So let's find the axis of symmetry. I'll write the formula here at the top. And we just have to pay attention to what b and a are. So for number 7, we have x equals, b is 3, and a is 1. So we get x equals negative 3 over 2. Axis of symmetry, negative 3 over 2. For number 8, x equals, here our b is a 1. That's the coefficient in front of this x. And it's over 2 times 2. So we get x equals negative 1 over 4. Or negative 1/4 would be the axis of symmetry here. So before we go on, we now know 2 ways to find the axis of symmetry. If you have the graph, we're just looking for that vertical line that we can draw through to split the parabola in half. And if we don't have the graph, we just have the function, we're going to use the formula negative b over 2a. Now this next slide has a lot of writing on it, and you can write it down if you'd like, but I'm not going to make you write it. So just make sure you're really paying attention to what we say here. So when you're finding the vertex, we can use the axis of symmetry formula. So again, this would be a case where we don't have the graph, but we're asked to either find the axis of symmetry and or the vertex. So we're going to use the axis of symmetry. Remember, the axis of symmetry is the x value of the vertex, and that's going to help us find the vertex of the parabola. And again, it's helpful if you don't have a graph of the quadratic function, or if it's difficult to tell, like in example 5. This one was difficult to tell where that vertex exactly was, so we could have used the formula for axis of symmetry plus another piece of information to help us find it. So the steps are, we're going to first find the x-coordinate of the vertex, or essentially we're finding the axis of symmetry. Then we're going to plug that number in to find the corresponding y-coordinate and write the vertex as an ordered pair. So in the previous lesson, when we were finding the vertex, we were literally just picking it right off the graph, but now we don't have the graph. So we need to find the vertex. The first thing you have to do is find the axis of symmetry. And that's with the formula. X equals negative b over 2a. So here we have our negative b. B is a negative 2, so we want the opposite of negative 2. So positive 2 over 2 times a is a negative 1. So that's going to give us 2 over negative 2 or negative 1. Remember again, the axis of symmetry is a vertical line. It's x equals negative 1. But it's also the x-coordinate of the vertex. So in step 2, we're going to take that x value, we're going to plug it into the function and get the corresponding y value. That will be our vertex. And so I'm going to go down to step 3 real quick and write negative 1 comma, and I'm going to leave a blank here because we're not sure what the y value is yet, but we're going to plug that x value into the equation. So we get y equals, a lot of negatives here, so be very careful, negative x squared. X squared is a negative 1 minus 2 times negative 1. So listen to my thought process here if you can't follow this. Negative 1 squared is positive 1, but now I need to make it negative. Negative 2 times negative 1, that's a plus 2. Negative 1 plus 2 is 1. So the y value that corresponds with the negative 1x value is a positive 1. So your vertex is negative 1, 1. Let's do another one. First we need to find the axis of symmetry. Remember, it's x equals negative b over 2a. So we get x equals, the opposite of a negative 10 is a positive 10 over 2 times 5. That's 10 over 10, or 1. So our axis of symmetry is x equals 1. That means our ordered pair is 1 comma something. And we find the something, we find the y value by plugging that 1 into the function. So we're going to plug the 1 in for the x, because that's what it equals. Don't plug it in for y. So we get y equals 5 minus 10 plus 3. 1 squared is 1, 5 times 1 is 5, 10 times 1 is 10. So we get 5 minus 10, that's negative 5 plus 3, negative 2. So the vertex is 1, negative 2. So we were able to find the zeros of the quadratic function by looking at the graph. And we were also able to find the axis of symmetry and the vertex of the parabola. We can look at the graph to find both of those pieces of information, or we can use the axis of symmetry formula to find both of those pieces of information. If you have questions about the notes, make sure you ask in class, and we will be working on worksheet 9.2a.